All right, a welcome from my side. Happy to be back again, actually, at this twice the size show this year. And it's my pleasure to kick it off with a few thoughts around the Spring Framework roadmap. This is actually a little more than a roadmap discussion, since Spring, of course, doesn't live on an island, right? It is very much part of the ecosystem of all the infrastructure around us. So we'll actually be talking about quite a few recent happenings around Spring. And, well, there are a few that are really worth singling out. For a start, we have a really decent level of Java 8 adoption, don't we? This is actually from October already, so shortly after the Spring Framework 5.0 launch. We have about, well, 3/4 of Java 8 adoption, according to several surveys. I picked the one from Eugene here from Beldang. This state of affairs is what we need. It's particularly important for us in order to justify a generation of the framework being able to require Java 8 as a minimum. So, of course, as you are probably well aware, Spring Framework 5.0 is Java 8 baseline, so it only runs on those 3/4. If there is any need on your end for Java 7 and 6, we keep you covered. Just stay on Spring Framework 4.3.x in its extended maintenance life. Right? So this is a great situation for a start, and I'm personally very happy that Java 8 adoption worked so well. And it's actually been close to that level even before. But it's particularly great to be at that stage now. Now, of course, there's plenty of things happening. We need to take into account that the JDK as we know it, kind of downloading an Oracle JDK installer, is not quite the way we're going to do it in the future. Everything is being channeled towards OpenJDK now. And that is also fundamentally a very positive thing to happen. The differences, the technical differences between Oracle JDK and OpenJDK are going to, well, be smoothed out, right? Everything, or most of it anyway, everything that's relevant is going to end up in OpenJDK, but it's also going to be our primary source of JDK distributions, because Oracle has a new release model for the JDK. And this new release model brings a new support model. So this slightly complex graph, which I actually borrowed from our friends at Azul, illustrates that we're going to get a new JDK generation every half year now. We already got JDK 9. We even already got JDK 10. JDK 9 is already end of life. JDK 10 is only going to be supported until September this year. Now, we all need to get used to this, right? Both us as framework providers, and I'm sure you as adopters, and in your upgrade policies, you have to take this into account. This is not the way we used to handle JDK upgrades at all. So, most importantly, there's a new long-term support definition. JDK 8, of course, is considered a long-term branch. This is this long red line down there. The next long-term support branch is JDK 11 as an LTS release coming our way in September. Effectively, JDK 9 and 10 are just short-lived intermediate feature branches. So JDK 11 is what we need to look forward to, but how do we actually get it, right? And we'll see in September in anger, right, in real life. But fundamentally, we're going to get it from OpenJDK. OpenJDK is this kind of central institution where a new feature release is going to be dropped our way every half year now. So it's going to be OpenJDK 11 that we will be using, and OpenJDK 12 half a year later, and 13 and 14. The long-term support nature of the JDK is a topic in its own right. The complexity of the support model behind it is quite a challenge for the providers, and I'm sure it will also be in practice in terms of setting upgrade policies for your systems. So long-term support branches you can get from several vendors, and we'll get back to that in just a moment. But fundamentally, there's two ways of handling it, right? Upgrade every half year, or buy long-term support for one of the long-term support branches. Not least of it all, we are seeing the end of Java EE as we know it. Java EE has been donated to the Eclipse Foundation, or more specifically, it is actually in the process of being transferred. It's not actually quite there yet in its complete form, and there are actually several issues along the way, right? The Java community process that used to handle many of the specifications here is a quite complex beast in its own right in terms of its setup, and transferring this to the Eclipse Foundation is a quite daunting task. So all the power to them in actually making it happen. There's currently no technical work on a new generation of Jakarta EE. We are all waiting for it to be fully transferred first and kind of to be re-released from the Eclipse Foundation. We're going to see why we particularly care on Springland, but we are a kind of participating member from Pivotal's side, from the Spring Group, because we do care about quite a few specifications, quite a few APIs in the formerly known Java EE, now to be known as Jakarta EE, and hopefully to be seen as individual specifications, individual APIs with an individual life of their own. That's what we're hoping for anyway. So last but not least, Kotlin, the big K, right, is really a huge factor in our release planning these days. We have first-class support not only for Java 8, the language, and kind of best effort support for everything that follows, like Java 10, the var feature, that sort of stuff. But we in particular provide first-class support for Kotlin, which is of course on its own already quite a huge story that is sort of decoupled from the JDKs, right? Remember, you can upgrade your Kotlin version staying on the same JDK generation if you choose to do so, which is a great feature of Kotlin in its own right. So where are we? Roadmap-wise, the Spring Framework 5.0 release is already out, but since Spring already out for more than half a year, but since Spring Boot 2.0 only got released a couple of months ago, many systems out there are still in the process of picking it up, right? So Spring Framework 5.0 is very thematic. We actually rolled many of the little features and the refinements in the annotation-based model. We rolled those into Spring Framework 4.3. So just in case you're wondering, right? Lots of the goodness that could have been in 5.0 in the details, lots of it is actually to be found in 4.3. So to some degree, to quite some degree, I actually recommend checking out all the little refinements in 4.3 while you're upgrading to 5.0, right? 5.0 is doing many things that can only happen in a major release. The Java 8 baselining, the broad efforts towards first-class Kotlin support, shipping Kotlin extensions all across the framework, a fixed nullable definition all across the source code. So we literally took the opportunity to revisit almost every source file in the core framework here. But from a higher level, it follows a functional API design theme. Functional as in Java 8 functional, Java util function, Lambda expressions, method references. Not only for Java though, also for Kotlin. And it tracks the JDK. The Java 8 baseline is a huge step to take on our end. I'm personally very happy that we're finally able to do this, to expose not only a lot of Java 8 goodness to your applications at runtime, but also to use a lot of Java 8 goodness within the framework now. Remember, Spring Framework 4.3 came with lots of Java 8 support for applications, but we couldn't use it internally yet, because the framework internally had to remain Java 6 and 7 compatible. And we're even Java 10 compatible now, as of Spring Framework 5.4.5. This new release cadence in Java land is quite a challenge for us, right? We don't wanna take our roadmap and kind of adapt it to the JDK iterations, so we have to take the JDK releases as they happen. If JDK 10 goes GA, and we are currently in Spring Framework 5.0x, then it's the next 5.05 release in this case, picking up JDK 10 and doing the usually minor things we have to do to make our build fully working on JDK 10 and everything smoothly happening for your applications at runtime if you choose to be on Java 10 already. However, it's not always that smooth. And the Spring Framework 5.1 release actually takes a few steps towards embracing Java 11. The forthcoming Java 11 for September is a bit of a challenge in some ways. It actually removes some formerly deprecated modules and APIs from the JDK umbrella, because deprecations in Java land happen in every single release now. If something is being deprecated in Java 9 or 10, it may get dropped half a year later in Java 11, right? So deprecations are not happening between long-term support releases. They are happening in every single half-year iteration. And in our particular case, we have to do a few things, like our runtime define class model, that we have to revise for Java 8 compatibility, in particular for compatibility with Java 8 on the module system. There's two things we really care about here, and that is taking existing applications onto JDK 11, existing Spring applications in particular, onto JDK 11 and having kind of a smooth, no-nonsense upgrade path. The other one is we want to provide a warning-free experience on Java 11. Even if there are quite a few warnings issued by Java 9 and higher that you can safely ignore at runtime, in particular on the class path, we want those warnings to go away, right? So a warning-free experience on Java 11 is quite a theme in its own right. Spring Framework 5.1 is time-bound. We'll have a release candidate sometime in summer, hopefully sometime July, and a GA release in September, along with JDK 8, with JDK 11's GA. So all of these things are going to happen in September, ultimately. And there's a few other things we're picking up. For example, Hibernate ORM has a quite major 5.3 release that recently went final. There's going to be quite comprehensive support for some of the new SPIs in that release, right? So it's not just about the JDKs, but it is the central driving factor. Beyond that, we have a few things on the planning horizon, but we always plan for the next iteration, really, since we never quite know when everybody else is doing their releases. So there's a loose plan for a Spring Framework 5.2 release next year. It's going to pick up a few things. That's kind of the current estimate, right, of what we need to do there that we can't do in 5.1. If Kotlin 1.3 is not released in time, we're going to pick it up in 5.2. We're definitely going to track Java 12. We're currently in a situation where lots of little things are going to JDK 11, actually quite a few removals, but some of the more ambitious language features are only going to start materializing in Java 12 and higher. Java 12 coming our way in March next year, March 2019. So I'm sure there's some good things we can do, some additional value that we can provide out of the box around Java 12 and higher, in particular Java 12 itself, where some of the held back things are going to be merged for the first time. So that is also a theme for Spring Framework 5.2. Not least of it all, the Jakarta EE efforts, right? Jakarta EE is hopefully providing a working environment for getting at least initial maintenance upgrades to the servlet specification, to the JPA specification, to beam validation, to common annotations. The JavaX.annotation package lives not in the JDK anymore. It's actually removed as of Java 11. It has a new home at Jakarta EE. This package where post-construct, pre-destroy, and that sort of stuff lives. So there's quite a few things we care about. And we can hopefully consume some of the work that we'll also participate in in those areas, in those particular specifications. Now, back to the JDK, to wrap up this storyline, a few additional thoughts on how to deal with the JDK support options in the context of a Spring application. I was already mentioning, if you want long-term support, there's limited options. You can buy commercial support from Oracle, from Azure, from IBM, who have a new development level subscription or like runtime level subscription for basically OpenJDK plus a few things. There's SAP, as far as I understand, largely as part of SAP products. Same goes for Red Hat at this point. It has yet to materialize what exactly the procedures are for those vendors to handle long-term support, whether you can buy it from day one, whether it's going to be a later date that they set. We'll all be wiser by September when kind of JDK 11 goes GA and everybody declares their actual support stories. There is also a commitment from a group called Adopt OpenJDK, which is effectively an IBM-sponsored group of volunteers, strong involvement from the London Java community, who intend to provide free long-term support builds for the long-term support branches. So effectively OpenJDK 8 and OpenJDK 11 updates for a longer period. Not quite as long as the commercial support contracts go, but as long as the primary support phases go. For the commercial contracts, that would be until 2022. Doesn't change the fact that it's only for the long-term support branches, right? It's your choice of JDK 8 or 11. Those are the only ones that actually have long-term support from anybody. So the next long-term support release would only be JDK 17 in 3 years' time. That's September 2021, right? So for quite a few years, we'll only have JDK 8 and 11 as our long-term support options. Now, a few considerations, maybe not strong recommendations, but ideas from my side. Consider staying on the class path. Sounds straightforward because that's probably where you are, right? If you have existing deployments that use the class path, that bootstrap a JVM with java-cp, with the class path option, consider just staying there. Don't bother with the module system unless you see actual value for your projects, for your systems in it. The smoothest migration path is on the class path. And in some cases, you don't have a choice anyway. If you're deploying WAR files to a servlet container, you use a different deployment model, a higher level deployment model. So effectively, the servlet container runs on the class path and provides WAR deployment for you. No need to consider the module system, really. At least not for direct consumption, right? You'll have the module system underneath the covers with all the benefits and some of the consequences, but you're not using it directly. Another, maybe a little more unusual recommendation, consider staying with the Java 8 bytecode level, at the bytecode level that Target 1.8 provides. That's what you're compiling towards right now. Maybe it's a good idea to keep doing that, even if you choose to deploy to JDK 11. So this goes into build against JDK 8, but run against JDK 11. The idea is that you have a defensive downgrade option, right? If you build a Java 8-based system as a Java 8-based service, you can always deploy to any Java 8 runtime. But of course, you can also deploy to JDK 11, and your chances of being successful, of surviving the smoke test, not just for your actual code and for the frameworks underneath, but also for your entire tool chain, they are significantly higher if you stick with the 1.8 bytecode level for a start, because all the existing tools understand that bytecode version. Whereas if you compile with JDK 11, Target 11, there's a new bytecode version, in particular in JDK 11, that your current tools with their embedded older ASMs might not quite yet understand. So for the smoothest upgrade path, basically don't change your existing arrangement, just consider JDK 11 as a deployment option. Get all the runtime benefits, no development time benefits yet, but all the runtime benefits of the JVM in its 11 incarnation and the Java 8 API and language level for development for the time being. Of course, in the long term, we all want to consume the new language and bytecode features. So this is only for a transition, but that transition may actually be a year or several years even. So this is the end of my storyline for today. We have a really interesting September coming our way. JDK 11 being GA as a OpenJDK 11 feature release, kicking off a new long-term support branch. Finally, after Java 8, dating back to 2014, we get a new long-term support branch this year. We'll join in with Spring Framework 5.1, going GA currently just around JDK 11, maybe even a little bit before. And we'll have Spring Boot 2.1 ready, at least in its release candidate stages around that time. It's a coincidence, but our Spring 1 platform conference, the kind of the American version of this conference, sort of but also the central pivotal conference of the year, is also happening in late September. So there's quite a bit of stuff to look forward to, and prepare yourselves, right, for this September. Give both the JDK 11 release candidates in summertime, the Spring Framework 5.1 and Spring Boot 2.1 milestones and release candidates a try. Give them a smoke test at least. Report any regressions. Make sure you're prepared and showing the ride in kind of this new generation from September onwards. Thank you. All right, we should actually have our next group of speakers coming up. I'll find them for you. There they are. The stage is yours.
Hi everyone, hope you're all doing well. So my name is Madhura Bhave, and this is Brian Clozel, and both of us are on the Spring Boot team. And we're here to talk about Spring Boot 2.0 today. But along with introducing what's new, we want to take you on a journey behind the scenes of the Spring Boot 2.0 release. We'll talk about some of the lesser-known details, what our thought process was, and why we made some of the decisions that we did.
So as you've probably heard about, Spring Boot 2.0 has been released last March after quite a lot of work, a lot of commits, and everything went fine in the end. But as you know, with Spring Boot 1x success, there was a lot of anticipation about when should it be released, how it should look like. So we worked on that quite a lot. But as you can see, the latest surveys and the feedback we're getting from the community seems to show that people are adopting quite quickly the latest release, even a few months after the GA date. So we're really happy about this.
Yeah, and like any successful first movie, making a sequel has its own challenges. So you can either exceed the expectations of your audience, or you can let them down completely. So with Spring Boot 2.0, it was important for us to strike a balance between familiarity and new things. And there was a lot of planning and execution that went into this release.
So because it's software and the movie analogy has its limits, we can't do whatever we want with versioning, unlike movies. So on our side, we've got to use semantic versioning. Because for software, we need the community to know what to expect when they're upgrading to the latest version. And in our case, because Spring Boot is an actual major release, for us it was the opportunity to have a new baseline, JDK 8 here, and as well upgrade a few dependencies and make breaking changes whenever it made sense.
And speaking about versioning, a large part of Spring Boot 2 was upgrading to Spring Framework 5. And with Spring Framework 5 being released in September 2017, the obvious question in front of the boot team was, when should we release Spring Boot 2.0?
Yeah, so the Spring Boot team, as a team, we wanted the community to use Spring Framework 5 as soon as possible. So the initial date we had in mind was the end of the year. But when we thought about it, we didn't want to really rush that release. We needed time to experiment. So we could have gone with another date, like the end of the year. But then, in that case, with the new JDK cadence and the new Spring Framework release cadence, we were in danger of being too late and being totally out of sync with the rest of the Spring ecosystem. So September 2018 wasn't the right date.
Yeah, and we were also integrating with other third-party libraries, and it was an opportunity for us to upgrade to major versions for those libraries. So we were tied to their release schedule as well.
So yeah, so in the end, we went with March 2018, and the clever rationale behind that decision was we wanted to be fast, but not that fast. That's it.
One of the things that helped us gain confidence in this release was constant feedback from the community. We did regular milestone releases. I think we had about 7 milestones before our release candidate.
Yeah.
And we got a ton of feedback from people trying out snapshots. So that was really helpful for us when we cut the 2.0 GA release.
Yeah. But even with all that feedback, we had our share of bloopers, I guess.
Yeah, we did. So there were some features that took us several takes to get right. And one of those was the application's global health status. So there was a ton of back and forth about adding a new actuator endpoint for getting the application's global status. But we even actually introduced that in one of the milestone releases. But in the end, it turned out that that was actually not necessary. And we just enhanced the existing health endpoint with some configuration options. So now the health endpoint can give you either the full details or the application's global health, depending on the configuration options that you can see on the screen.
Yeah, so one of the features that actually made it was the Spring Webflux support. So now with Spring Boot 2, you can use Spring Webflux, and the big deal behind it is we had to figure out all the reactive stories, how to integrate them with Spring Boot, how to add a whole new web framework in Spring Boot. And
yeah, so with movies, you have remakes. And initially, there was a lot of confusion about whether Spring Webflux was a remake of the existing Spring MVC framework.
Yeah, and actually, when you think about it, it's not about a remake. It's more about parallel tracks stemming from the same story. So they continue to evolve, different things coming from the same universe. But they're different things, different use cases. And in our case, what it means for Spring MVC and Spring Webflux, we have different features, but in the end, as a Spring Boot user, you still have the starters, actuator support, the auto configuration properties, everything. That was strange.
I'd forgotten about that. So metrics was another big theme for 2.0. And in Spring Boot 1.x, we had some basic support for metrics. But as the requirements got more sophisticated, it made more sense to pull it out into its own project that Spring Boot could then auto-configure.
Yeah, so now with Micrometer, you can have like a way better support in Spring Boot, so you can export your metrics to many different systems. And because metrics are now multi-dimensional, you can query them on a particular tag or on a particular dimension, and you've got a much better and much thorough support with your own metrics. And that's an example of what you can get from the metrics endpoint. right now in the actuator.
So this release, apart from adding new features, it was also about looking back at things that didn't work for us in the 1.x line and fixing those in 2.0 so that we have a better foundation laid for us for our future releases.
Yeah. So one of those is actually property binding. So you probably know about it, right? In Spring Boot 1x, you're able to have a configuration class, a configuration properties class, where you define a namespace. It looks like a POJO, it is. And you can actually bind things to that object in your own application. In several ways, you can use kebab case, camel case, etc. So this is how things worked and work still, but there were still a few issues with that.
Yeah, so people were confused about when to use relaxed binding. There were some issues with lists. Binding to lists was unpredictable, and binding to sets was just not possible at all.
And dealing with bugs was quite tricky, wasn't it?
Yeah, we'd always push the bugs to the next milestone. So I think that was a good indicator for us to rework our entire binding logic. So we wrote a new binder API, and we've also tightened some of the rules for relaxed binding. So now there's a uniform format for reading properties. Bugs with lists have been fixed, hopefully.
Yeah.
And binding to sets is now possible.
Cool. The other one is probably about security, because in Spring Boot 1x, people felt that the auto-configuration and the support we had for security was maybe a bit too much, and that in some cases it could be confusing. So we worked on it for Spring Boot 2.0 as well.
Yeah, exactly. So in Spring Boot 1x, we had auto-configuration for the application itself. Additionally, if you had the actuator dependency on your class path, we'd provide separate auto-configuration for the actuator security. And then if you added custom security, this auto-configuration wouldn't back off as expected, so you'd end up in this ordering issues with all the security configurations and not get the expected result. In Spring Boot 2, the main goal was to really simplify the auto-configuration that Spring Boot provides out of the box. So we rely on Spring Security defaults for both the application and actuator security. And as soon as you add custom security configuration, the auto-configuration detects that and backs off immediately.
Right. So we worked on many things, but some of those aren't really visible at first, but when you actually use the project, it makes a big difference. So back early last year, we had a team meeting when we thought about a lot of things. We worked on a lot of things, and we worked on some important issues like label colors, bike shading. Who doesn't do that? But we worked also as well.
Yeah, but apart from label colors, we also tried out new ways to streamline our issue triage process so that it's more obvious to the community what milestone an issue is going to go to. And now, actually, there's less issue triage angst among the team about whether the issue has been assigned to the right milestone. So for example, with the current process, if you see that an issue is assigned to the 2.0.3 release, there's almost like a guarantee that it'll be in the 2.0.3 release.
We also migrated our CI to Concourse. So for us, that's a big deal because right now we have several build pipelines, and we're running and we're building Spring Boot on different containers. We're in full control of each container. We can configure the actual JDK building. So that's how we deal with JDK compatibility right now. And because we like code, the whole configuration, the whole build pipeline setup is actually written as code checked in our own repository.
Yeah, you might think it's not such a big deal for you, but it actually helps us a lot when we're debugging build failures, because we can actually use Concourse's hijack command and jump into the container to see why the build failed. We also have our build, release, and pull requests all in one place now, so it really streamlines the process for us.
Right. So as a hat tip to the community, we also added a special feature to Spring Boot 2.0 because we love banners. We added a new support. We don't know if we're already aware of that. So here's a sample application to show you what you can do with animated banners.
So you could argue that this is the most useful feature.
Works.
Worked. Yeah.
Right. So this is our first sequel, not the last one, obviously. We're definitely counting on you to keep us on track and tell us what's working, what's not working. You can join us on Gitter, GitHub, and Stack Overflow. We're always there. Feel free to reach out and join the community.
Yeah, and unlike movies, you don't even need a ticket to watch the sequel. You can just go to start.spring.io and try it out.
Yeah. Thanks, everybody. Thanks to our contributors. We good?
Yeah, I think we can.
Okay, is this thing on? I'm already 12 minutes over, according to my monitor, so it must be coffee time. No, seriously. Hi, I'm Dave Syer. You know who I am, right? And my Twitter handle's up there if you need it. So I'm the awkward guy who doesn't use a Mac. Who doesn't use a Mac? Yay! Thank you, everyone. So I'd like to talk to you today about, it's a thought piece, right? I'll hopefully get you thinking a little bit and show you also a little bit about the direction of travel of some things in Spring and some things in Pivotal generally, because Spring is important to Pivotal. And it's about platforms. And I started talking about platforms, I don't know. It wasn't 10 years ago, but it was more than 5 years ago, right? Cloud Foundry, I think, was sort of 2011, 2012. And in those days, nobody really knew what I meant by platform, but I think everybody does now. So this is more, this is kind of an interpretation of what I see on my Twitter timeline at the minute, which is, you probably have the same echo chamber, right? You probably see the same things. Lots of people bickering about serverless. What does it mean? Is it the same? Is it different? Is it, how does it fit in with everything else? And, honestly, I don't want to bicker. I don't think there's really that much to discuss. It's all quite interesting. And this is what I'll show you. And the thing I want to get to is this idea of platform convergence. Everybody is sort of coming together in the end, if you look at it the right way, squint a bit. So this is how I'm going to phrase it. So I'm going to start by talking about what is serverless. And I've got a talk later on I think today. It was scheduled for tomorrow, but we had to switch it around. So look at the schedule and come to my other talk about Spring, serverless Spring, and you'll see what we've been doing there from the Spring point of view. But more generally, what is serverless? Serverless is these things, and for different people it means different things, and different things are important. But one or more of these things will be important to you if you're getting into the serverless game. So dynamic resource utilization, which often means scale to zero. You're not using any resources if you're not executing code. So that goes to the billing, that goes to the sort of business logic separation. And the other thing that people are excited about with serverless is integration with things, other things, platform services. And so if you're on Amazon, you have a different set of services than if you're on Google, which is different than if you're on Microsoft, which is different than if you're operating in-house. And that's an interesting situation to be in. So Juergen used the word island, which is interesting because I used to do this presentation where no app is an island, and I used that to introduce Spring Cloud and what Spring Cloud is about. And now you've got applications or systems that look like this one. I stole this from Jan Kui. I hope he doesn't mind. I shared a stage with him at a conference earlier this year. I like his work. So go and look at theburningmonk.com if you want to know more about what he's doing with Amazon Web Services. So this is a pretty small, actually, business application written using lots of little AWS lambdas. And things increasingly look like that. Another picture that I borrowed from my colleague Kenny Bastani, who's probably in the room, is sort of a more obvious picture where it's sort of like a traditional hexagon. That's a microservice, right? Hexagon equals microservice. Talking to a data source, but also with this sort of swarm, a comet tail of lambdas, of functions, sailing behind it, doing little bits of work for it. I think that's an interesting model as well. So it's sort of a little bit freeform, right? It could look, this is idealized, it could look a bit like this. So here's a question for you. If you're interested in microservices, if you're implementing them, you're probably thinking about bounded contexts and domain-driven design. That's a really good thing. That's a really good way to frame that discussion. But where is the bounded context on this diagram? Is it there? Or is there one there as well? Or is it maybe the whole thing? And that, I think, is a little bit fluid at the minute. People haven't really decided what to do, architecturally speaking, I think, with serverless. So that's to be developed. So there are a few things missing from serverless as we see it at the minute. One of them is architectural cohesion. Another, which was actually a thing that Jan was talking about in the presentation I stole that slide from, is observability. Everything is much more granular, and everything's talking to everything else. So you need more higher level tools to make sure you know what's going on. And then there's this tension in between the vendors and their platforms, and the fact that, how many people in this room work for a bank or an insurance company or one of the big traditional enterprises? Probably a lot of you. You probably don't use Amazon Web Services very much in that case, because life as a developer in those kinds of institutions is FTP file transfers, it's legacy databases, it's SAP, it's integrating with all this messy stuff. And Amazon Web Services just doesn't actually help very much. So on-premise and bring your own services is going to be an important enabler if anybody is going to actually, in real life, in real business applications, use this serverless stuff. So more often than not, this is actually what it looks like. So you might think it looks like that, but actually it's more like that. So what's going to happen? Well, I want to talk about this convergence idea and about abstractions. So abstractions are a good thing. We all know that. But abstractions are also complications. So you treat them with caution. And in the context of this discussion, not everything is a function. All right. So serverless is great. Functions are great. But not everything is going to fit the same abstraction. Here's a sort of cloud abstractions layer diagram that you'll be familiar with. Everything's built on virtual machines these days. Everything probably is in a container these days. Then you actually get to the point where I'm interested as a application developer, a user of Spring, apps, and then sitting on top of the layer cake, functions. And those are, roughly speaking, embodied as services in these kinds of ways. Okay, so these are the sort of traditional abstraction tools for thinking about how to implement technology and systems in a modern enterprise. So what does it all mean? So you've got different levels of abstraction. The higher level of abstraction means you push more stuff down below you. You don't care if you're writing a function about the container that it's running in at all. You don't care if you write an app about the operating system that it's running on. You just don't. So you push stuff down, but that means you get less control of it. Okay, so that's sometimes good, but sometimes bad. So you need to pick your battles. Not all abstractions are useful for all problems. And that's why we should stop bickering. We should learn that everybody's abstraction is a good one and try to apply it where necessary. So this is kind of what we need. We need to have, as a developer, I don't at all care about, at this level, virtual machines. Come and talk to me later if you think I'm wrong about that, but I don't. So I care about containers, apps, and functions. And what I would like as a developer is actually something that brings them somewhat together, right? Lets me pick the abstraction and run my code in the way that it deserves to be run. So the developer doesn't care what's in the middle, really, but you do care about the abstractions at the edges. And so what we've been thinking about in Pivotal is how to provide that, I guess, as a product. So we've got these labels: Pivotal Application Service, Pivotal Container Service, Pivotal Function Service. And what's in the middle, I'm not going to say what it is, but you probably know what that icon is. It's probably going to be that. It's not certain, but it's probably going to be that when it comes down to it. And so in that box, just to let you know what's happening, the PFS, where it says Pivotal Function Service, what we're building is an open source project called Riff, and I'll be talking about that in my other session. So I won't be going into any more detail about that now. But I guess the message at the end of the day, so this is the end, and my time is still up. The message at the end of the day is abstractions are good, but they complicate life. They can complicate life. You need to pick the right abstraction, and you need a platform that lets you do that. So it's going to be interesting to see how we move on from here, but that's where I think we're going with Spring. And as a Spring developer, I'm quite happy with the way things are developing. If you want to know more about Java and serverless and Spring on serverless platforms, come and see my talk later. Thank you.